All right, so in the last video, we just basically put our data values in here. Now I'm going to take you through the process of interpolating between 20 and 30, and then 30 and 45. So previously, I just gave you guys a template, but now I want to walk you through it. And so the first thing that we're going to do is we want to increase our angles down to 45. So the best way to do that is just to grab maybe 4 of these angles right here, and then say fill, and let's just drag down to 46. I think that'll be up. Need one more. So that's 45 right there. Okay. And we want to go ahead and grab our initial velocity here. I'm going to say fill, and let's just drag this down as well. The initial velocity is not going to change for these angles. The amount that goes into the x direction and the amount that goes into the y direction will change, but the resultant vector will not change. So let's go ahead and do the same thing for our radians. Our angle in radians is just a calculation, and it is based on the angle in degrees. So the angle in degrees times pi divided by 180. There's a function in here that'll work as well. So we're just going to fill this and drag down. Okay. And then a for our quadratic equation is going to remain the same. So I can do the same thing here. Yep. Oh, too much. And then our b, which is a calculation, is just the initial velocity, which is 3.1, times the sine of the angle in radians. So we want to make sure we pull all of that down. Just say fill. Then we can drag on down to this location. So as you can see, the angle, the velocity in the y direction is just increasing. And now we have increments. This is what I've not done with you guys. Well, I haven't done a lot, but this is one thing that I want you guys to look at. So we have G22 minus G2 divided by 20. G22 is down here. It's actually the 0.129. So it's G, this is 22, and then this is G, minus G2, which is here. I'm taking these two values and then I'm dividing them. I'm taking the difference between those two values, and then I'm dividing them by 20 so that I can get 20 increments. Now what I want to do is I want to do the same thing here, and I wish I would have put all of those cells in between, but I'm going to have to do it kind of manually, so I'm just going to have to insert above. Uh-oh, looks like I have a mess here now. So let me just take these two values. I'm just going to cut them, and I want to paste it down here in 30. And then I want to take 18, and I want to cut that one and paste it down here in 45. So those are our values for those particular locations. So let's go ahead and just set our increments. This is going to be equal to about 16 centimeters minus 12 centimeters divided by 15. Isn't that right? 20, oh, it should be 10. Sorry, not 15, 10. So once you have that, that's beautiful. Now we're going to say equals to the one above it. We're just going to refer to it. And then we're going to grab that value and fill and drag down to the location right above where 15 centimeters will be. Okay. The next thing we'll do, so those are our increments between 13 and 16. Now we need to increment between G4 47, and G 32. And we're going to use the same method. Say equals to. I'm going to go down here and select on this value minus this value. Now this is going to be divided by 15. So I need to go ahead and say equals to 2 millimeters, and then we're going to fill and just drag this down. And I'll stop at that location because we'll do more interpolation like this later on. So the first thing that we want to do is we want to add our increment to our previous value, which is from our verification, which is 0.129. So I'm going to select on this. I'm going to say equals to 0.129 plus our increment, and hopefully that'll be representative of what's the angle at 21 degrees. So we're basically saying it's going to rise that much. Now we can select on this fill and then drag to our known value. And as long as it's not greater than this 1.5, we should be fine. If you add the next increment, like 0.29 to this, it should go up to that point. So we're going to do the same thing here. I'm just going to say equals to what we have before, right here, plus this one. And it's putting in a whole bunch of decimals. Oh my goodness. So I probably want to fix all of those decimal places. Even though we can go down to 6, we definitely can't go down to 15. And then since we are adding, it's only going to be as good as 4 because of the significant digits. If we were multiplying, it would be something a little bit different. It would be about accuracy. So I'm just going to say fill and then drag this down. All right, and look at that. We have 18, 0.183, 0.185, 0.1869, about 7. So that's good right there. Okay. And now we want to select on our time of flight here, and remember that it's just a calculation. So I'm just going to fill and then drag this down. You shouldn't have any complications here. Okay. And they are steadily increasing, so the time of flight is high. And then we have our angles again. So in this particular case, you see we have 30 here. Let's just go ahead and say fill and drag over the 30 and the 45. You know what? I better not do that. Let me go ahead and delete these two or clear them. And then fill and drag down to this location. So we have 45 degrees there. And remember that these values here were calculations that were based on, and I wish I could have kept them, but they basically changed when I changed the angle. But these calculations were calculations that were based on our graph. So we don't need them anymore. Because our predicted range is actually a calculation too. So let's get rid of this, clear that. Let's fill, just drag this down. So 3 decimal places should be fine here. And that's looking good. Okay. And now let's bring our measured. So I'm just going to cut this and go down to 30 and paste. And then I'm going to cut this and go down to 45 and paste. All right, so our error reduced significantly, okay, and it's starting to balance out a little bit more here. All right, and the very next thing we'll do is just select on our graph and then drag all the way down to represent what we are expecting to get. And notice that the line is now curving. And we would have error bars where you might have 9% on one side. It's good to within 9% on both sides. So if we want to reduce this, we would have to make our experiments better. Now this particular line doesn't fit, or this equation, it only fits for the straight line. All right? And that will be it for this particular assignment. Looks good all the way through. So I'm just going to back this up. And remember to go into your Dropbox and share that file with me. I'm just looking to make sure that everything is there. This is the wrong one. Alternative hypothesis, still the wrong one. Okay, so you'll see all of those things. Now you should have 3 videos in here, as well as 3 snapshots. Okay, and that will end this series of videos, or this experiment.